All right. We've started recording now. So again, good morning, everyone. Welcome to the Carpenter Working Group. As we get started, let's do the project updates first. So is there anything that anyone wants to just update the group on? Any project updates?
Did we talk about the 1.4 release in the last working group? I can't remember if that was before or after.
That's a good one. I don't think we've talked about that since I don't think we've had the working group since last week. Um, so yeah, I can pull up the chain log. Anything in particular you wanted to call out?
I think the main thing is just the performance improvements, the new preference policy. So allowing users to opt to have Karpenter ignore preferences, like prefer no schedule constraints for topology spread and affinity. The other thing for the AWS provider was we now have support for custom SSM parameters for Omni discovery. So that was contributed from the community, and I know a lot of people were looking for that. I think those are the main callouts I have.
That's awesome. I think one thing that I could also call out is an improvement that we have made to the scheduling or provisioning. Um, a lot of customers basically wanted Carpenter to not spin up additional capacity when, let's say a drift or like a particular node is blocked on a pending pod, which can't be evicted due to the do not disrupt annotation, or let's say there is a PDB which is just too strict for those pods to evict. So we have released this change wherein if you have like pods with do not disrupt annotations, Carpenter will not spin up additional capacity for that pod to reschedule. Similarly, for PDBs which are too strict, so stuff like 100% available, 0% unavailable. So this should consider cover, I think, most of the cases that customers have complained about. But again, I mean, if there are if there's more feedback, the original issue is still open. So I'd love to see if this solves the problem or if there are other things that we still want to look at. All right. Does anyone have any other callouts? All right. Think we can move on to the RFC then. Are there any RFCs that we want to discuss today?
Yes, I had one RFC that I wanted to mention around the testing story that we're planning on doing for the upstream project. I just simply don't have access to my account right now, but I've linked it into the chat. Um, Main thing here is that we're going to be migrating some of the cloud agnostics testing that we have for the AWS provider into the core project, and then we'll be utilizing the Guac provider. This will better enhance our ability to validate changes that we do to the core project much more quickly and give us a better signal. One other big positive here is going to be that other cloud providers can just import these tests into their own testing frameworks with their own providers and have validation that the upstream, well, I guess core tenants of the upstream projects have not been violated. If you have a chance, please go feel free to add comments. We're looking to merge this in. It's been open for quite some time now, so we're looking to hopefully merge this in soon.
Sounds good.
Cool.
Thanks, Emmanuel. Sorry, did I interrupt someone?
Yeah, I think I also had one to talk about, unless there are any other comments on this. It's not quite an RFC, but I put up the draft for expanding Karpenter's on-demand capacity reservation support to support capacity blocks. This does include a small design basically on how we're going to handle the interruption handling for capacity blocks, and also like what labels will be available for scheduling two capacity blocks. So if anyone is interested in this feature, please feel free to take a look and leave comments on any feedback for the design. It's not a big one, but yeah, may interest some folks.
All right, does anyone have any comments? I'm guessing everyone just needs time to review this. All right, any other RFCs that we want to discuss today? Right, I'll take that as a no. Coming to community questions, it seems like we have one here, so I'm gonna open this up. Jeremy, do you want to talk about this?
Yeah, I just wanted to follow up on this. I think it's ready for merge. It's more just asking for a re-review, more than talking about it. It's for the change to allow not syncing taints from node claims to nodes.
I had left a few comments. Were you able to get back to those?
I believe so. Yeah.
Oh, okay. I just missed it. Sounds good. I can take a look
Okay.
later today.
Yeah, no worries.
All right. Do you have anything else on this, Jeremy?
No.
All right. Any other questions for today? See your raised hand. Go ahead, Elmico.
Yeah, so I have a question, and this maybe, I don't think it's related to the capacity block stuff, but it's a question that's been coming up in the cluster auto scaling groups. It's getting more attention now in like the main Kubernetes community, especially like with the node lifecycle working group getting started and everything. But I'm curious, like, how does Carpenter react to instances where um, it might take time for hardware to arrive on the instance, right? So, like for example, GPUs, I think are probably the classic example of this, where we have pending pods or we have pods that are unschedulable. Carpenter decides to make a node based on the notion that it thinks there will be a GPU there. The node gets created, but the GPU is not yet visible on the node. And so what does Carpenter do at that point? Is there like a mechanism for synchronizing this type of behavior?
Yeah, there is. So this is the distinction between registered and initialized. So Carpenter doesn't consider a node to be initialized until all of the extended resources have been registered with the node. And up until that point, Carpenter will keep scheduling pods against it in its simulation as though it had those extended resources. So Carpenter doesn't just see a node come up. It thought it would have GPUs, it doesn't, so it tries to create another GPU node. So yeah, that is the purpose of initialization.
Okay, cool. And then I guess like as a follow-up to that, have we thought about this in terms of like CSI drivers where you might not know ahead of time that a CSI driver could be placed there or when it will arrive there? I guess is that up to the provider to implement, like how you would go from like registered to initialized, or is there another mechanism for that?
So I think in the case of CSI drivers, at least as far as I'm aware, they're not going to be publishing any resources to the node itself. You do have the use case for the ephemeral taint, which is added to the node at the beginning to make sure that the CSI node can come up first and get its volume limits populated. But I think that's really the only use case we've heard. Yeah, I'm not aware of if there are any others.
Okay. Yeah, I mean, there's like a interesting problem with like the CSI, there's like a CSI node object or whatever that helps
Yeah.
to define like what ends up there. And, this is a problem that I've been talking with some folks about in the relation of or in the reference of the cluster autoscaler, but they've been asking me like, okay, well, how is Carpenter going to handle this? Um, because like I think Carpenter and the cluster autoscaler kind of look at things very differently in terms of how they're planning, what
Yeah.
they're planning to make or whatever. And so there is this weird behavior, I shouldn't say weird, but there's just this really non-deterministic behavior with the CSI drivers where like, you might expect that a CSI node object will eventually land for the node, but you're not sure what driver types will be there. And so you think a certain type of driver type will be there, but it might not arrive or it might arrive very late or something. And
Mhm.
I'm starting to try and think about, is this going to be an issue in Karpenter. But it sounds like maybe I need to spend more time looking at the, kind of registered versus initialized and some of those mechanisms.
Yeah, so this is slightly different than the extended resource story for like GPUs, but what
Yeah.
people usually do is you add a taint, like a startup taint to your node pool for the EBS driver or like the EFS driver, whichever CSI driver you have. That taint is then removed by the driver when it is ready. So, and that is how you prevent pods from scheduling prematurely before that CSI node is ready. Um, I know that there are some investigations into better ways to handle this in a more common way for all CSI drivers from just some conversations I've had with folks on the EBS team, but I'm not really aware of what those are. But for the most part, this solution works pretty well for Carpenter, with the caveat of the fix that Jeremy is pushing through for making sure that we don't resync that taint onto the node.
Right. And I see Ivan talking about this as well. And I think, actually like the Azure like CSI driver code actually does this automatically. It'll put like a taint on things where things are coming up. I'm really like kind of trying to understand this holistically because I think there's going to be probably attempts to make this more standardized in Kubernetes. And so like I'm just curious to hear like how different projects are handling it because I think when we finally get to the point of making this more standard in kind of core Kubernetes, I just want to make sure we kind of understand all the options and everything. So I
Right.
appreciate the discussion here, and thanks for the information.
Yeah, of course.
Thanks for asking this, Amika. I mean, fairly uncharted territory for me as well. So definitely something that I need to dive into. All right. Do you have any other questions? Going once, going twice. All right. I'll take that as a no. I think that's all we have on the agenda for today. Any other questions that are not on the agenda? Anything anyone wants to discuss?
Um, I do have a quick question. I'm not sure where it fits there. But in a case where we have a cluster with multiple size, multiple families of, instance, I'm wondering what is the recommended approach for block device mappings. Right now we have a single EC2 node class with one size of, EBS, but in some case we might need more or for larger instant families, but less for smaller ones. For example, we might have a lot of Docker pools that like, you take some of the storage and it's not like one size fit all. There's no automatic resizing in the EBS side, I'm assuming. So I'm wondering like where folks are using there to, be a little bit more FinOps conscious so we're not overspending on storage when you don't need it. Like you end up creating multiple, EC2 node classes per family, or you have a centralized or dedicated one that you can share and then just swallow the cost. Because I'm assuming there's no auto resize of the EBS right now in Karpenter. I could not find anything like that.
Yeah, it's not something Karpenter natively supports. There is an open feature request for right sizing ephemeral storage based on the pod requests. This isn't something we've moved forward with yet, but is something we're open to, but would need design. I think right now your best option is either multiple node classes, which does have its own trade-offs. Or I think I've seen a lot of users use the D class instances with NVMe for their ephemeral storage. So those, you kind of get a similar scaling to what you're looking for.
Okay, thank you.
But yeah, this is something we're definitely interested in expanding, but yeah, it is a bit of a complicated problem to solve, right? So it would need some design.
Yeah, makes sense. Thank you.
Jason, if you don't mind, can you share the feature request here?
I can try and find it. Yeah, I'm going off memory.
Thank you.
But I can add it to the doc after the meeting. If I can't find it quickly. Yeah, that looks like it's the one. Thanks, Ivan.
All right. Any last items to discuss for today? I think we can end early today. Have a nice day, everyone, and I'll see you all next time.
Thanks.
Thanks.
Thank you.